Okay, so for any angle that's a multiple of pi over 6, pi over 4, pi over 3, and pi over 2, um, we can get those right off the unit circle. But what you got to remember is that like, so where does it fall? Like the problem you posted was we have to find the sine and cosine of negative an angle of rotation was negative pi over 3. Well, I know negative angles of rotation start here at 0 and they turn clockwise around the unit circle. Okay, so what you got to decide is where it falls, right? Now, one time, this is not my invention. This Oxbow student a lot of years ago came up with me when we were doing this in a pre-calc class. She said, "Oh, all I got to do if I got to figure out what the reference angle is, and we're like, so where it's going to fall is all I got to do is look at the denominator if it's in this form of pi in terms of pi. So what you can do is see how I know negative angles go this way. I know that the reference angle had the 3 under it. So see how that's 6, and that's 4, and I don't know if you can see this over my scratch there. And so that's where this angle right here is where negative pi over 3 falls. Okay, see how the 3 and the 3 match up? So that's where it matches up. And if they were looking for the sine of that angle, if we're looking for the sine of negative pi over 3, well, that's going to be the y coordinate. Remember, for each of these points on the unit circle, um, it's sine of the angle, comma, sorry, you get that backwards. I don't believe I did that. Sine is y, cosine is x. So cosine of the angle is the x coordinate. Sine of the angle is the y coordinate. So what's the sine of negative pi over 3? Well, since this is where it falls, that's going to be the value. Negative root square root 3 to 3 over 2. And what's the cosine of negative pi over 3? Well, that's going to be the same as the x coordinate, which is 1/2. Okay? And then we can keep going here. Let me clean this up and we'll do some more. So what about the sine? Oops, sorry. What about the sine? Now I'm assuming you're okay going around. Well, let me do this. What's the sine of 2 pi over 3? Well, I'm going to start at 0. I'm going to start at here. Let me delete that part too. Delete that. We don't need that. Well, not all of it, just that. So 2 pi over 3, we start at 0, 0. We go in a counterclockwise position because it's in a direction because it's a positive angular rotation. And all we got to do is find 2 pi over 3. So the sine is going to be the y coordinate, and it's going to be positive root 3 over 2. You see how the denominator, how the actual values are the same. It's just the SIGN, the sign is different. And that's what it falls. So I'm that okay, and the cosine of 2 pi over 3 is going to be negative 1/2. One other thing I'll do before you end, and might as well since we're talking about this, one thing gets asked of you on this myopia math assignment, plus I'm going to ask this of you on a quiz. I think it's next week's quiz, as a matter of fact. Oops, I'm going to keep that, delete that, delete that. I'll start easy, then we'll get a little we'll go a little harder. So suppose I want to know some angle. What angle has the same sine? Sorry, what has the same sine as pi over 3? Say, we'll keep it easy. So the sine of pi over 3. Remember, sine is the y. Pi over 3 is root 3 over 2. So what we're going to do, and it's a positive, so what we're going to do is go around and find out where the y value is the same thing. And I'm hoping you're thinking, oh, that's pi over 3, or 60 degrees. So this is also pi over 3, and you see how that y value is exactly the same. So the answer to this will be the same. So what angle has the sine of pi over 3? That's going to be 2 pi over 3. What angle has the same cosine as pi over 3? Well, the cosine is the x coordinate. So if this is 1/2, we've got to find where else is this angle equal to positive 1/2. And if this is an angle of pi over 3, this has to be an angle of pi over 3. And as you see how that's 1/2 also. So that answer would be negative pi over 3. However, I think in the MyOpen Math it asked you to find an angle between 0 and 2 pi. So in that case, we've got to come all the way, start here, come all the way around, and you're gonna tell me 5 pi over 3. So that's how you do it this way. Okay, I guess let's talk about angles that are bigger than 2 pi. Suppose I had to find the cosine of 22 pi over 6. So this is actually going to be, if you think about it, 2 pi radians is 1 rotation around. And because this is divided by 6, I mean, I guess we could reduce that. Let's make this so it's not reducible. Here, we're going to make it be 23 pi over 6. That way it's not reducible. So what we're going to do is we're going to think about the way, here's what I recommend you do, and here's how I think about it. 2 pi is the same thing as 12 pi over 6. The reason I want to write it as over 6 is because this is over 6. So then we got to think about, I'm going to do 1 full rotation around, so I'm subtracting 12 pi over 6 off this. So 23 pi over 6 minus 12 pi over 6 is going to be what? Isn't that going to be 11 pi over 6? And 11 pi over 6 is less than 12 pi over 6, so I know I've only got 1 rotation left to go. So let's see if I can clean this up a little bit so I can see the circle. So that tells me the cosine of 23 pi over 6 is going to be exactly the same as the cosine of 11 pi over 6. 11 pi over 6. So 11 pi over 6 is right here, and we're looking for the cosine, so that's the answer is going to be root 3 over 2. Okay, so keep subtracting off the values until you get something that's less than 360 degrees or less than 2 pi, and then you can get that answer. So I hope that's okay with getting the common denominators doing that. Now, probably the last thing I should do in this video is talk about finding, and that again, finding an angle that has the same sine of another. Suppose I want to find two angles, about one angle. Well, we can do two angles. Let's do two angles between 0 and 2 pi that have the same sine as the sine of, or actually, we'll better not use 2 pi because I'm in degree mode. Let's say 360 degrees. Same sine as sine of 75. So here's the way to do this without a lot of effort. I know 75 degrees is right there. And I know that reference angle is 75 degrees. I know that in quadrant 1, all trig ratios are positive. I know in quadrant 2, sine and sine, you don't know about cosecant yet, so sine. Down here, tangent. Down here, cosine. And if you've watched my other video about this, all seniors turn crazy, or all students take calculus is a way to remember this. So anyways, that reference angle is 75 degrees. So the angle, and sine is positive there. So where else in this quadrant, in the four quadrants, is sine also positive? Well, you're probably already saying, Dan, it's over here. But the reference angle will have to be exactly the same, and I write 40 for some reason. 75 degrees will be there. So what angle is this? So what we're going to do is we're going to take 180, subtract 75 from it, and that's going to give me 105 degrees. We'll have the same sine as 75 degrees. What angle has the same cosine as 75 degrees? Well, again, it's a reference angle of 75. The only place the sine, here cosine is positive. The only place the cosine is positive is down here in quadrant 4. So that's going to be a 75-degree reference angle. That tells me this angle is going to be 360 minus 75. What is that? 285. Let's see, I'm sorry, I got to do this. That's 5, that's 10, yeah, 285. That's 2, and that becomes 15. So 285 degrees has the same cosine as 75 degrees. So you got to think about the reference angle, decide what quadrant it falls in, and then you can go to town and get that answer. I hope this gives you what you need. Let me know if it doesn't.